We are on part 08. I will be releasing part 09 today or tomorrow, so you should study it. But now, I don't know if you remember from last week, we did a standalone TCP/IP communication. That's when we had two nodes, two processes that communicated with each other without ROS. Then, on last week's practical class, we did exercise 3, in which we did a mirror exercise where two processes communicated between themselves using the ROS infrastructure. So 3 is like the ROS version of exercise 1. Now, we also had another exercise, which was exercise 2, where we had a serialization example. In this example, we were again communicating with between two nodes, a special information which was contained in a dog library, okay? And in this case, we had to serialize, put some commas, then take away the commas, just for you to see how difficult it was. And now we are going to do exercise 4, where we are going to see the ROS equivalent of that, okay? So, how can we start from the beginning? So, if we are going to be supported on the tutorial for the creation of messages in ROS, because since we are sending a custom information, so it's a dog library, which contains, if you remember the name, the age, blah, blah, blah. This is not a message that is standard in ROS, so this doesn't exist in ROS. And what we need to do is to create a new one. That's why we need to create a new message, which is a procedure that is not done that much often. There are so many readily available messages in ROS that typically you can just use one that already exists. What are the messages in ROS? For starters, we have this standard ROS messages. Okay, STD messages. So these messages will define the basic elements such as a char, a float 32 bytes, 64 bits, a string, something like this. Okay, so these are the basic elementary types, message types, which you can use to build up the more complex messages. For example, a message with 3 numbers and 1 string, this kind of stuff. So let's first look at the code that we had. I need to turn on PyCharm. Let me see if I can use my glasses, because I'm starting to see very badly. Okay, so now we have this, and I'm just going to use this PSR part 08 exercise 3, which I'm not sure if I did on last week's P1 or P2, but anyway, let's use this one. So if you take, let me shut down everything. So right quit all, and if we go here, we had a publisher and a subscriber, if you remember correct, if you remember. What did the publisher and the subscriber did? They were publishing messages from the publisher to the subscriber. Let's run it again just for us to remind ourselves of what we were doing here. So I'm going to open a terminal. I'm going to do a ROS core here. You know, a ROS core is always needed. Then I'm going to the proper place and I'm going to, so here I have the publisher, so I'm going to run the publisher. Publisher.py. So the publisher just says, I don't know what to say. And it says it. We can run here the subscriber. The subscriber listens to the message, I don't know what to say. If we run the RQT, I'm just reviewing exercise 3. That's why I'm going fast, because we've seen this before. You can see that the talker publishes on a shatter topic some messages, and then on an A17 topic some other messages. We've discussed two different things in last week's conversation about topics and messages. So the first thing, when a node wants to communicate with some other node, is that we need to establish a communication route or infrastructure. That's the highway in the case of the cities, the examples of cities, or it can be, for example, if you are thinking about persons talking to each other, it can be a topic of conversation. So for example, I speak with him politics and someone else sports. Those are topics of conversation. So when I start speaking about politics, only Lucas will listen. And when I speak about sports, Sarah will listen. That's the equivalent to the road codes that we had before. So we have topics, but these are just infrastructures. And then, as in the example of the roads, on the roads, you have some cars, some vehicles passing through the roads. These vehicles that go from one to the other are the messages. So now you have two concepts, topics and messages that go through. And you can have several messages over time, of course. Now you have a third concept, which is the type of the message. Now, all the examples we've done last week, no matter the topic, all of them were sending string messages. It was just text from one place to the other. But we could send different things. So for example, we can send from Aveiro to Porto through the road, not only vehicles, but some other kind of messages, some other kind of vehicles, for example, trucks instead of cars. So there is this third concept, which is the type of the message. If you take a look at the code from last week, we were always using here, when we defined our publishers, the type string. And this string comes from the standard messages of Ros. So these strings that we were sending, either in the Chapter topic or the A17 topic, were always being listened by the subscriber because they were also expecting a string, okay? But we can change this. We can put something else here. For example, instead of string, we could use some other Ros message type. Of course, that if we did that, we wouldn't be expecting the text to go from one place to the other, but for example, a number, something like this. In this case, what we are seeking is to create a new message type that we are then going to send from one place to the other, okay? So first, this part of creating the message type, and then the second part of using it. So how do you create the message type? You follow the guidelines step by step. So if you go to this tutorial, this tells you how you can create messages. Messages are specified in a special, a special or unique .msg file, which must be inside an MSG folder. So first we create the MSG folder. Inside our Ros package, not a file, a folder, sorry. MSG. Then inside, so I did this mkdir. Then we are going to put something inside the MSG, which is a file called something.msg. In this case, if you read the exercise 4, our goal is to send the dog information from one node to the other. So let's call it dog.msg. So I'm going to create here a dog.msg. Okay? So we have a new file, a dog.msg. Now, this is a Ros message that is going to be sent from one node to the other, and we have to decide on its content. So what should it have? If you remember the example from the dog last week, the dog had some name. The name is a text, a string. So we have to specify here string. We can say here string because string is a type of Ros standard message. So we can use any kind of Ros standard message there. So we are going to say string name. That's the first property of our dog. Now we need to define the age. The data type for the age could be, for example, the integer with 8 bytes, uint8, because uint8 goes from 0 to 255. It's not reasonable to expect a dog to live longer than this. So we can just use uint8 age. Now we have to define the color. If you remember, the color was encoded in a text, so we just say string color. And finally, we have brothers, not one, but as many as we wanted. It was a list, so with variable size. It was a list of texts. So text, list, brothers. Okay. So here we have 4 fields in our message: the name, the age, the color, and the brothers. And this is the specification of the message. Now, if you are wondering why we are using a special format for defining the messages, so you could ask, why is this not Python? We are always using Python. The reason why this is not Python is because we can have, so ROS is all about communicating between processes. And the question is that these processes do not have to be written in the same language. So I can do some code which is going to communicate with some other code. My code is in C++ and the other can be in Python, for example. For them to speak to each other, they must be one of them, they must know which message one of them is sending, and the other one must know the message or the message type that he is receiving. Therefore, this message specification must be derived for all the languages supported in ROS. And this part here is called the generation of the message. So we specify this in a .msg, because then when we compile the package, it is going to create the necessary files to Python, C++, Lisp, Java, blah, 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 okay? Therefore, and then we will be able to communicate using many languages. All right, so how do we proceed? We proceed in the tutorial. So after we define our message, we are going to do whatever says here. So we are going to uncomment in package XML these two, okay? So message generation and message runtime. I'm going here. I'm going to my package XML. Sorry, here. To my package XML. And I have here my message generation and here my message runtime. I uncommented both. Then, next step is to go to the cmakelist.txt, which is the folder that configures how the compilation of the package is going to be, what the compilation is going to be doing. So we go to cmakelist.txt. I can put this to the left, and I can put my PyCharm to the right. So if we go here to my cmakelist.txt, it says, okay, now you search for the place where it says find package and put there a message generation. Okay, so here is the find package, message generation. Okay? Check 1. Check 2. You search for Catkin package and you add this Catkin depends message runtime. So I'm going to search for Catkin package. Search for the Catkin depends and add their message runtime. Okay? Check 2. Check 3. Search for the place where it says add message files and uncomment and put there your message name. So add message files, where is it? I'm going to search. Okay, this is it. Okay, so my files will be just one called dog.msg. That's what I called it, right? Yeah, dog.msg. Okay, check 3. Let's go to the next one. So this one is the same. Now, then you need to uncomment the place where it says generate messages. We search for the generate messages, which is here. So I'm only following step by step all the checks that it says we should do. I never remember this, I just follow the procedure. And after this is done, we just have to compile the package. How do we compile the package? If you've done the Catkin tutorial, it shows how you can create a workspace and then compile the packages. So to compile the packages in ROS using the Catkin, you go to the catkin workspace. So this is the directory, and then you run catkin make. This will compile the packages. What does it mean to compile the packages? It means a lot of stuff. It means to compile C++ code into the target objects. If you know, if you've used C++, you know what I'm talking about. If you don't, you obviously don't understand, but this is about compiling C code, which we don't have, so this part is not happening. And then it does more stuff, in particular, this part about generating the messages, okay? That's what it's going to do now. So this is taking a lot of time because I have many raw stuff in my computer. For you, it should be very simple. And it created the messages. Look at what it said. This part. Yeah, Pedro. Yeah, I will answer just a moment, okay? So what it did was to generate the messages. You can see here what it's saying. I'm generating C++ code for this message. I'm generating Python code for this message. I'm generating JavaScript, Lisp, Eurolisp, and blah, blah, blah for this message. So that's how you can have this multi-language functionality in ROS, because it does this kind of magic. Now, just before going to Pedro, the way we can check that the message was correctly built is to use a command called ROS message. If you do ROS message -h, it says, okay, I can show info, list, and blah, blah, blah. Okay, let's use ROS message list. I have a lot of messages on my system, you see? But I can grep, you know the grep command. So the grep command will search for this output, and it will search for a pattern called dog. So I have 3 dogs, one from P3, that's from this morning, another one from EX4, that's from last year, and this one is from today, right now, okay? And now I can say, okay, so this is a dog message. So these are not all the same messages, different messages, because the parent package counts. So what does it contain? I can do ROS message show ESR part08 dog. Okay. Okay, so message dog contains a name, an age, color, and a list of brothers. So that means the ROS ecosystem already recognizes the message you have created. And because of that, you are probably going to be able to include it in your code, okay? Now, for the question that Pedro asked, what he asked was, when we want to compile our code, we need to compile it from where it is. And my fast answer is no, because of CC. What does it mean? That's what it means. What I mean is the following. Yes, in Catkin, you always have to go to Catkin workspace to run Catkin make. If, for example, you go to the source and run Catkin make, it doesn't work. If you are on home and run Catkin make, it doesn't work. And this is a bummer, because I'm typically in a terminal somewhere very far away from the Catkin workspace doing something, and then I have to go back, Catkin make, and then I have to go back again to the place where I was. So this is a bummer. So what did I do? I did the CC. See if you understand what I'm doing here. So .zshrc is the configuration of my terminal. It's not .bashrc because I have a different terminal, but it's the same as far as you're concerned now. And what I added here was where is my alias? No, not this. Yes, I added this one on line 109. What does it mean? It means that when I type cc enter, instead of cc is going to replace cc by catkin make -- directory home, the tilde is for home, catkin workspace, and then -J16 is to use 16 processors, okay? So the way to solve this bummer of having to go always to the same place to run, so if I do here catkin make, it doesn't run, But if I do cc, I'm actually doing catkin make. So if you do catkin make minus h, it says, oh, you can do catkin. Oh, wait. Yes, you can do here. What is it? Minus minus directory. Well, I don't see my directory. Minus help. Ah, it's on the top, no? Oh, where is the directory here? Ah, it's here. Sorry, I didn't see it. The second one. So I'm just calling catkin make with this option. So I'm doing catkin make minus minus directory home mic catkin workspace, and this works. Okay, so I'm just doing cc. So I recommend that you put cc in your .bashrc. So that's it. Now we go back to the code. Remember, we defined the message, we compiled it, we tested, and it's included and visible within the Ros ecosystem. Therefore, we can now go and use it in our code. How? Simple. Here we are importing a string from the standard messages. Okay, so now let's import from the PSR part 08 exercise 3.msg, import something called dog. Okay, so now I'm importing the dog message from that. And I have to use the dog here. Instead of publishing, this is the subscriber. I should have started with the publisher, sorry. Let me start first with the publisher. It's better, I think, to understand. So first, let's go to the one who publishes here on the left. So this guy, again, is going to use the class dog. So it should from psr.msg import dog. Now I'm going to use the dog. So I'm going to comment the message, the string, sorry. And here I'm going to use, well, actually, I don't have to comment the string. Let's use the string still to send a shatter from one place to the other. Or let's say the string will still send for in topic A17, the shatter will contain a dog. Okay? So now I'm sending two messages. This is a double publisher, which publishes on the topic shatter messages of type dog, and on the topic A17 messages of type string. Now, to publish a dog, I can't just say, remember this dog stuff is the pub, no? So here I cannot say pub.publish text to send, because text to send is not a dog. So I have to create here, create a dog to send, a dog message. So how do I create a dog message? Dog equals dog. This is like creating an instance of class dog. Then I create a name for the dog, some age for the dog, some color for the dog, and let's say that it has brothers, sorry. Let's say it has two brothers, Lily and my name, Bobby. Okay. Okay, so I've just created a class of dog, which now I can send using the publisher pub. So I just put here my dog, okay? So not so that I don't make any confusion, I'm going to comment everything else which doesn't have anything to do with sending the dog, so you don't get confused, okay? So simple, create the dog, send the dog, that's it. Now, on the side of the one who's listening, what we need to do is, of course, to say that we are listening to a dog instead of listening to a string. So we just change here to dog. It works because I already did the import there. Now, what is the problem? When I receive a dog, I'm going to call this message. And before this message was of type string, if you remember. If we go to the Ros standard messages, and if we go to the string data type, it contains a field called data. This is the reason why here we go to msg.data, this part here, okay? Now, in our case, our message, if you recall, let me put it here for you, contains a field with the name, another with the name age, and so on and so forth. So we cannot print this, we have to print some other field. So let's just say, received a dog named msg.name plus which is msg.age. This is an integer, so I have to convert it to text. Years old. Does it make sense to everyone? Yes? All right, so now we can test. So let me restart the Ros ecosystem. And if I now run the publisher, it doesn't print anything. Before it used to print, but I commented the print. So I commented this, Rospy log info is the print. So that's why it's not printing. And here the subscriber is going to subscribe. And now he's receiving a dog named Max, which is 18 years old. Okay, so now we are passing information from the publisher to the subscriber, and this information is custom. It was created by us in the new dog message. Okay, so that's it. Is everyone clear with this? No questions, nothing? Okay. So can you try? Well, I will leave it for you to do it at home. I don't think you need to. We don't have enough time here to make a lot of tests. Here, let me show you what you should do at home. So there is a different way of communicating in Ros. It's called a different communication paradigm, which is the one we were using is the publish subscriber, which is the most simple one. The publish subscriber is the one where a node starts speaking and other nodes may listen or not. And the number of listeners is variable from 0 to n. So it's the example I give always is the crazy guy who goes to the town square, puts himself on a pedestal and starts speaking. So it just speaks on and on. Sometimes people may listen if they are interested, and sometimes nobody's listening. This is the publisher subscriber. Now there is a second paradigm of communication, which is the server client. This is more similar to the one we have used in exercise 1. And the difference is that the server is passive, is just listening, waiting for the client to send a message, typically requesting something. Oh, give me something. The server will then reply, okay, here it is. So the server client is a bidirectional communication. The client asks, the server responds. Whereas in the other case, the publish subscriber, this is a unidirectional communication. The publisher speaks, and if you want, as a subscriber, you listen. But there is never information going on the other way. In this case, what we are asking on exercise 5 is to do a service. So you are going to extend your node to create a service, okay? So you should try to do this. I will not do it because I don't have enough time, but I really recommend you to do it. Don't forget, I gave you an extra week. So now take advantage of it and don't lose the train of Ros, because if you don't study now, even if you study a lot in 2 weeks, it's not going to be enough. For next week, apart from this exercise 5, you should prepare the new part, which I'm going to show you now, which is part 09. So now we are going to start getting deep into Ros. The first part that we are going to study, where is my, okay, solutions here. What, Emmanuel, you would need another week? No, that's what you're saying? No. Okay, you have to study. Don't sleep. You didn't come to Portugal to sleep, did you? Okay, so exercise 9. Wow. Where is my? I'm in Paris. Okay, I'm in Paris. So thanks. PSR Social, here it is. Okay, so part 9. Here, part 9. So the idea now is that we are going to look at how Ros provides functionalities to configure the nodes without us having to write any kind of code. You've seen before from the examples that we gave already that we can launch from the same code different processes. So one process can be launched from a code, and then you can launch another process using that same code by, for example, changing the topic type or the topic name, sorry. And Ros provides a lot of stuff for name remapping, which is quite interesting because this is all about reusing the code. If you can parameterize your code to change the topic name and blah, 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 you don't have to write new code every time you want to change something. So this is about remapping. Then we are going to talk about Ros parameters, okay? And private parameters, and files, parameters with files. So this is all about the functionality that Ros uses to facilitate the work of a programmer. And we are also going to discuss launch files. So you can see you have a lot of work now in front of you. Just try to do it at home, because I think you can have some fun doing this. I'm not sure, is this a figure or what? Yeah, it's a figure. So you can see that we have a lot of stuff to do. From next week onward, I will not have time to speak about everything. So don't wait for the class to cover everything, every little detail, because this is too much now. And I'm just going to select the most difficult ones or the ones where I have time to talk about, okay? So if you come to class without not even taking a look at name remapping and this kind of stuff, it's going to be hard. Try to take some time to study this, okay? That's it. Anyone else needs something? All right. Have a nice weekend.
O professor vai colocar este novo ficheiro no Git?
Como assim, um ficheiro no Git? Eu posso pôr? Sim, exatamente. Olha, vou pôr já.
Ou pelo menos o vídeo da aula, só para nós seguirmos com mais calma.
is asking if I'm going to put this in Git. Yes, I'm going to push now so you can use it and take a look. So, part 08, exercise 4. Já está, Adaltino.
Obrigado, professor.
Qual fim de semana, pá?